Okay, humans. Hi, how's it going? We're going to talk about probability. Disjoint probability, overlapping probability, independent probability, and dependent probability. Well, dependent events, or dependent events, independent events within the idea of probability. So, what does it all mean? Okay, let's go to an example. Okay, so here we have a little spinner thing over here with a little arrow that designates where it lands. And we've got 1, 2, 3, and 4 section. Colored red is the 2 and the 4. Colored blue is the 1 and the 3. What's the probability of getting a 1? Of course, it's 1 to 4, right? That makes sense. What's the probability of getting a 1 or a 2? Well, there's two distinct ideas here. There's a probability of getting a 1 or there's a probability of getting a 2. The probability of getting a 1 is 1 out of 4, we just discussed. Probability of getting a 2 is also 1 out of 4, but the probability that you could get either one is, of course, 2/4 or 1/2. These events are said to be disjoint. Now, let's complicate things. I said number 2. Okay, so number 3, let's say the probability of getting a 1 or a blue. Well, what's the probability of getting a 1? We already discussed this. Probability of getting a 1 we know to be 1/4. The probability of getting a blue, let's make this a bit smaller so we can talk about everything. Oh, there it goes. All right. Probability of getting a 1 is 1/4. Probability of getting a blue would be 2 out of 4. But there's a problem here. These events are overlapping. Because there is a blue that contains a 1. There is a blue that's also a 1. So we need to subtract for our overcounting. There is, again, 1 out of the 4, and there's 2 blues out of the 4, but there's also a 1 that's a blue. So we need to subtract this overcounting that happened. And now we have 3/4 minus 1/4 is 2/4 or 1/2. Huh, cool beans. Here's another spinner. You've got half of it red and half of it blue. What's the probability of spinning and getting a red? 1/2, of course. Now, what's the probability of spinning and getting a red and then a red? A little different here. Well, let's go through the unique possibilities that are within reason. You can spin and get a red, or with your first little spinny poo, you can get a red or a blue. Okay, well, if you got a red, you could spin and get a red or a blue. Well, if you got a blue, though, when you originally spun, you can spin again, if you so desire, and get a red or a blue. So out of the total possible scenarios here, I see one that gives you 2 reds. One out of the 1, 2, 3, and 4. There's only 1 out of the 4. Just so happens, if you're looking for something and something else to happen, like getting a red and a red, you can solve this by multiplying the probabilities together. Goodness gracious. So you've got 1/2 times 1/2 is that 1/4, which is your final answer. Interessante. Let's take this and apply it to somewhere else. Okay, here we go. We have our spinner handy just in case we need it, and we have this big bag of marbles. Now, I know this is a highly unlikely scenario. What would have been more likely is if I drew a giant named Nathan, and then there's all these people, and Nolan got picked for dinner, and things like that, But we're going to stick with this unrealistic example here of a little bag with marbles in it. Let's play with probability for a little bit. What's the probability that you reach in the bag and gain a blue marble? Of course, 2 out of the 5 marbles. There's 2 blue out of the 5. Now, if I put that marble back in the bag with replacement, I'm replacing that marble, assuming that I got lucky and got a blue one, or whatever one I got, I'm going to put it back in. So then what's the probability of getting a red? You would then say 3/5, right? Okay. What's the probability of getting a red and then getting a blue? Remember, I just said the probability of getting a red and the probability of getting a blue. Well, we just learned if you hear and, you can multiply the probabilities and you should get your answer. Probability of getting a red, you can see it's 3 out of the 5. Now hold on a second. Is this with replacement or without replacement? Because if it's without replacement, how many blue marbles are there? 2. But if we chose one already, here, we only have 4 marbles remaining. So this would be without replacement. And they'll tell you this beforehand. They'll say, what's the probability of finding a red and a blue marble without replacement? So you look at the probability of finding a red, 3/5, and multiply. The probability of finding a blue would be 2, and now out of the 4 remaining marbles. Sick. So the answer would be 6/20, which simplifies down to, is it 3/10? Delicioso. Before we move on, let's discuss how this is an independent event. The spinner doesn't change. The marbles don't change if you have replacement. So the spinner is an independent event, and so is the marble situation if you replace. If you don't replace, the probability gets changed. So the probability depends on what happens before. Dependent events without replacement. Independent events with replacement. Dependent events depend on what happened before. Independent events are unchanged, like the spinner or like the flipping of a coin. Depending on what happened before, it doesn't matter, because if you flip a coin the 100th time, you still either get a head or a tail. Sick! Alright, this should help a little bit. I want you to do the rest of the work. Congratulations. Bye!